right, hello everyone. Welcome back to the last week of classes. We have only one lesson this week. It is on expanded equations of circles, so we're going to just get right to it now. I did this yesterday, and then my screen recorder app crashed at the very end of the video, so I'm going to try and get this done a little quick, but not too quick, because I don't want you guys to be lost. All right. Sometimes you may get an equation for a circle that is not in the standard form. Here's an example of an equation not in standard form. When this happens, we have to use algebra to change our equation into standard form before we can identify the center and radius or graph it. And the algebra skill that we need to change an expanded form circle equation to a standard form circle equation is called completing the square. I do not know if you learned about this in Algebra 1, but I believe it is technically supposed to be a thing you talk about at least a little bit. But anyway, we're just going to learn it today, just in case. You'll also need it next year, so like if you can remember this for next year, Mr. Richards will be super impressed when you are like, this is easy, we've done this before. All right. Completing the square is a process in which we take a binomial, two-term polynomial, with a quadratic or x squared term and a linear or regular x term, and find the missing constant, which is just like the number with no x's, term to make it a perfect square binomial. So that's when it's like x plus a constant squared, like this. Yes. All right, so here we've got x squared plus 4x equals -1. One thing we want to think about whenever we're talking quadratic equations, they're always going to be the form a x squared plus b x plus c. All right, so a is just a coefficient for an x squared, b is a coefficient for a regular x, and c is a constant. And that's just like a thing that people use to refer to the three numbers that you find in your quadratic equation that are on the left side of the equal sign. This can be whatever. When we're factoring, it's usually 0, but we're not factoring today, so it's not. All right, so to complete the square, we want to think, what could I find? So I've got x squared plus 4x, and I need to think, what constant term could I put here to make this so that I can factor it down to x, plus or minus something squared. And over here we've got a -1, so we got to figure out what goes in this blank. And if we add something on the left side of our equal sign, we're going to have to add the same thing on the left side, otherwise it doesn't stay equal. So I'm going to put the same blank over here and just know that they're going to have to be the same number. And all we need to do to figure out what that number is we're going to look right here at our b. So the number that goes in here is going to be b over 2. Well, that was a bad parenthesis, squared. All right, so 4 is b, so we divide that by 2 and get 2, and then we square it. 2 squared is 4, so we're adding 4 on both sides. And then when we go back to think about what goes in here is actually going to be just b over 2, right? 4 divided by 2, 2. And so we have just completed the square. I'm going to go ahead and erase this b over 2 squared, so make sure you write that down. Pause it if you need a second to write it down before it gets erased. All right, so then we've got this. We can factor it to a perfect square binomial x, and since it's plus here and it's plus here, we know that we're going to have the plus, not the minus. Plus. Oh, that got really bad. Let me just redo that whole thing. We're going to have a plus and not a minus. Sometimes it'll be a minus. If this is a minus, then it can be a minus. Actually, it has to be a minus if this is a minus. You can't even see what I'm gesturing at, probably. If this is a minus, then this has to be a minus. These are going to match. this should always be a plus because it's a perfect square. All right, so we've got our x plus 2 squared, erasing that b over 2 part at the bottom as well, because that's not necessary either, equals to negative 1 plus 4, that's 3. All right, so we've just completed the square. I'm sure that there's a reason why we were supposed to complete the square. I just found this as a random example on the internet for completing the square. So there's no real purpose to this exact exercise, but the next one we're going to use it to do circle related stuff. Okay. I'm sorry, I just ate lunch and there's like something in my teeth. Not bad, guys. Should have checked on that first. Okay. So on that first slide, I gave you an equation, and we're going to complete the square twice to turn it into a standard form equation for a circle. So we've got x squared plus y squared minus 8x plus 2y equals negative 8. We're going to just rewrite that in a way that works better for most brains, I think, to look at to complete the square. My brain for sure. So x squared minus 8x. We're going to leave a plus blank, right? Because we don't know what's going to go there yet. Plus y squared plus 2y. And once again, we're going to leave a blank equals negative 8. And since we have 2 blanks over there, we're going to put 2 blanks on the right side of the equation. All right. So then we're going to check out. All right. So here we've got b is negative 8. So we're going to divide that by 2. Negative 8 divided by 2 is negative 4. Then we're going to square it. Negative 4 squared. I should write this down. So b, let me just, negative 8, b over 2. We're just dividing by 2. That's negative 4. And then, b over 2 in parentheses squared. I mean, I guess I don't have to put it in parentheses. No, I do, because if I typed it in the calculator, it would just square the top. Anyway, then negative 4 squared is going to be 16. All right, so that's 16. We're going to put that 16 over here as well. Remember, what you do on one side, you have to do on both. And then we're ready to break this down, or unbreak it, smush it, we're factoring it, which is technically breaking it down anyway. We're gonna factor this. So first term x, because there's nothing in front of the x, and we won't be doing anything that has something in front of the x in this class, because that's Mr. Richards' problem next year. Okay. And then since this is a minus, this has to be a minus, and then what goes here is going to be our b over 2, our 4, since we already got the minus. So it's x minus 4 and squared. Make sense? Make sense? Good, got it. We got one more practice with the second one. So here we've got our b is 2. And then, so b over 2 is equal to 1. And b over 2 squared. 1 squared is still 1. Make that more of a b. So here we're just putting in a 1. And here a 1. And then we can bring this guy down. Boop. Y, since this is a plus, this is a plus. 1. B over 2 is 1. Squared. All right. Switch back to the blue. All right. And then we've got negative 8 plus 16. That's going to be positive 8, because 16 minus 8 is 8. And then plus 1, so that's 9. So this is, believe it or not, a standard form equation of a circle that we've just gotten. And it tells us that our circle would have a center at positive 4, hence why it's a minus x minus 4 means that our center's got a positive x, and negative 1. And it would have a radius. Since on this side we've got the radius squared, the number that you square to get 9 is 3, so our radius is 3. Oh, I did it again. All right, so moving on to the next slide, you'll understand why I said that in like right now. It says, once we've completed the square and gotten the equation into standard form, we can identify the center and radius, then graph our circle. Our previous example solved down to this, so we're identifying the center and radius. Literally just did that on the last slide. This is why I was like, oh, right, because I spoiled the surprise, you guys. Center is 4, negative 1. Radius is 3, because 3 squared is 9. 4, because it's minus 4. Negative 1, because it's a plus 1. And use the opposite sign. Use the opposite sign of what's in here, which is probably the most confusing part of circle equations, if you ask me. Which no one did, because this is a video. All right, so now we're going to graph it, which is the part that is a little trickier, but luckily there's no way for me to like test you guys on your ability to graph circles by hand, because we're online and I'm not going to ask you to like send me photos of your graphed by hand circles, because that would be too much. Grading submissions that I have to actually grade is too much for me. All right. So we know our center is at 4, negative 1. Our radius is 3, so it needs to go up to at least 7. So say this is 8, 7, 6, 5, 4, 3, 2, 1, 0. Hi, Lucy. My cat is meowing at me, and my phone just went off. It's a very busy time. All right, so this is our x-axis, our very poorly drawn x-axis. It's from negative 1. It's got radius of 3, so it needs to go at least to negative 4 over here and positive 2 over here. So let's put it negative 5, negative 4, negative 3, negative 2, negative 1, 0. Let's just put it here for funsies, right? There's still stuff in my teeth, you guys. It's so uncomfortable. All right. So let's go ahead and we will graph our center point. She's like ignoring me now. So 4, negative 1. I've done goofed this. I have messed up immensely. I have completely, totally messed this up. I am so sorry. So the 4 is how far over it's got to be. So 7. So 8, 7, 6, 5, 4, 3, 2, 1. Let's put our line here. I like completely did it backwards of what I needed to do because I'm silly. All right, and then, so this is our y. I know that that's weird, right? All right, and then negative 1, so let's put it right. I'm so bad at drawing straight lines. All right, so let's go ahead now and we will graph the center of our circle at 0.4, negative 1. So 1, 2, 3, 4, down 1. All right. And then all we're going to do next is we're going to graph the 4 points north, south, east, and west of our center that are 3 units away, because that's the easiest way to count on a graph, directly sideways or up and down. So 1, 2, 3, 1 here, 1, 2, 3, 1 here, 1, 2, 3, 1 here. Whew, barely fit there on the graph. 3, 1 here. All right, so can you see those points? Make them a little darker. And just know that they belong on the like cross place of the grid lines. And then we're going to go ahead and we're going to do our best to sketch a circle out. This is the hardest part, is making it circly. All right, let's go. Woo, halfway. Oh, done goofed. All right, try again. There we go. All right, yeah. We got ourselves a circle. And that's it. That's how you graph a circle. Again, I am not actually going to test your ability to hand graph circles, but now you know how to do it, which I think you might also need in Algebra 2. So if you can hang on to this knowledge for that long, I don't know if you'll actually get to circles or when you do, but they're definitely a conic section, which is the thing that is technically part of the Algebra 2 curriculum. All right, so up next is, let's see. All right, so we can also create equations of a circle if we're given 3 points. Oh, this is such a long example, but we're going to do it. We're going to power through. Power through, I say. All right. So we've got 3 points, A, B, and C on our circle. A is at negative 8, 3. B is at negative 4, 7. C is at negative 4, negative 1. So I want to have at least 8 in that direction. So let's start at negative 9, negative 8, 7, 6, 5, 4, 3, 2, 1 to make my y-axis. Again, graphing is a very fun and confusing thing for many. Well, fun for few, confusing for many. Right, okay. And then it needs to go at least to positive 7, so 8, 7, 6, 5, 4, 3, 2, 1, 0. All right. We'll put our y-axis, or our x-axis here. See, all kinds of confused today, you guys. Should have done this tomorrow, but it's too late now. No turning back. Unless the screen recorder crashes again and then I just redo it tomorrow anyway. Hopefully that's not what happens though. I don't want to make this video 3 times. I'm already making it twice. All right, so then we want to graph our points. Negative 8, 1, 2, 3, 4, 5, 6, 7, 8, comma 3, 1, 2, 3. All right, here's point A. Point B is at negative 4, 7, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. All right, that's up here. B and C is at negative 4, negative 1, so same number over, but instead of up 7, we go down 1. And what we're going to do is we're going to connect those dots to make a triangle. And why are we going to do that, you might ask? The answer is because triangles can be inscribed inside a circle and have special properties. Do you remember what those properties are? This looks really weird today. It didn't look this weird yesterday. Something's wrong. 1, 2, 3, 4, 5, 6, 7. I see what's wrong. I graphed A at negative 7, comma 3 instead of negative 8, comma 3. That's why it's wrong. Let's fix that. All right. Right there. At least I recognize that it was wrong before we did all the math part. We just had the coloring part. Coloring is easy. Math is not as easy. All right, there we go. That looks better. This is what the triangle should look like. Look at my kitty. I'm going to show you my kitty. She's super cute. She's like right over there. Do you see her? She's right there. She's licking her shoulders. All right, that's my cat Lucy. She's the best. All right, anyway, back to math. So our next step is there's this property of inscribed triangles, wherein if you find the perpendicular bisectors of two sides of your inscribed triangle, they intersect at the center of the circle. So we're going to find our perpendicular bisectors now. And what we can do, we got to look at the slope of each of these. We're going to do the one for AB and the one for BC. Let's start with BC because it's really easy. So BC, we can count how many units it is because it's straight up and down. And since it's straight up and down, we know that perpendicular to straight up and down is straight side to side. Or in other words, perpendicular to vertical is horizontal. Math words, sort of. real words. All right, so straight up and down, straight vertical, and we can count how many units it's 1, 2, 3, 4, 5, 6, 7, 8 units. So halfway is going to be 4 units, which is going to be this guy that I am drawing in light blue. All right, so that's cool. And now we need to find the slope and midpoint of AB in order to graph that line's perpendicular bisector. So for AB, the slope is going to be, the y2 minus y1, so 7 minus 3, over x2 minus x1, which is negative 4, minus negative 8. All right, we got our 2 minuses there, which means it's a plus. So 7 minus 3 is 4. Negative 4 plus 8 is also 4, so the slope is 1. The opposite reciprocal of 1 is going to be negative 1, so our perpendicular line will have a slope of negative 1. I'll reiterate that when we get to that point. And then we want to find our midpoint, which we find by adding the x's together and dividing by 2. So negative 8 plus negative 4 is negative 12. And we divide that by 2. And for the y's, we add 3 plus 7, which is 10, and divide that by 2. All right, so our midpoint of that line, negative 12 over 2 is negative 6. 10 over 2 is 5. I feel like this 2 in particular looks like a 1, but it's a 2. All right, so negative 6 comma 5. We want to find that point. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. That's here. All right. And just to reiterate, since our slope of AB is positive 1, the opposite reciprocal, the slope of its perpendicular line, is going to be negative 1. So we just want to go, negative 1, which is like this, and like this. And we see here where the intersection of the two perpendicular bisectors is. We'll mark that in another new color. There's so many color choices. So that is the center of our circle. And then we have to find the radius. And normally we would use the distance formula, but I see that we've got points on the circle that are just vertical or horizontal from the center, so we can just count 1, 2, 3, 4. So our radius is 4. Our center, that's at negative 4 comma 3. All right, and knowing that information, we can now write an equation for our circle. So start by, nope, I've already started it wrong. Starting with x. So let's use a different color too. I like changing the colors. That's the best part. All right, so x. All right, we do subtract. Just making sure you guys could hear me that whole entire time, because earlier my microphone was muted and I didn't notice. So x, we want to subtract negative 4. So minus negative 4 turns to plus 4, right? Squared plus y minus 3 close squared equals, since our radius is 4, we want to square that, 16. Some people like to write it as 4 squared, but I think that's silly, so I don't do it. And that is our standard form equation of our circle. We're going to do another color. Yeah. This is a very colorful slide, you guys. I hope you like it. I worked very hard. All right, so that's it. We've now found the equation of our circle. It doesn't say to graph it, but if we wanted to, we would just graph one more point. 1, 2, 3, 4 right here, and then connect them with circle-y bits. Which this, since I'm going so fast, is going to turn out really badly, but it would look something like that. And that's it. We have found the equation of a circle given 3 points. We're going to have 2 of these in our check-in, which is going to be on Canvas this week because Khan Academy is a hassle to check and Canvas is less of a hassle to check. So we're going to scroll on down. All right, so to finish up this lesson, make sure you check out the stuff that is assigned on Khan Academy. You don't have to do the exercises, but if you need some help, they will be helpful, probably. If you need help that the Khan Academy is not helping with, office hours are still happening every day for 2 hours. So please stop by. And so there's videos and exercises on Khan Academy that you can look at or work on. They are not required. In fact, I think every step that involves Khan Academy might even say optional in parentheses right before the words. So pay attention to those because that means it's not required. If you are having trouble understanding completing the square and you think a different way of thinking about it would work, there is a link to the Maths is Fun explanation, which doesn't work for my brain, but maybe it will work for yours. Your brain is not the same as my brain, so different explanations might work for our brains than others. My brain is having a rough day. All right, finally, you want to make sure you complete the Canvas check-in. It says and Khan Academy exercises that are assigned for this week, but really the only ones that's required is Canvas. Canvas is required, Khan is not, and it is not for extra credit unless it specifies that it's for extra credit, which I don't know, maybe one of them does, who knows. All right, grades are due Friday, so late work cannot be accepted. All assignments are going to close before 8 a.m. Friday. I have decided that they are going to close at 11:59 p.m. on Thursday, so make sure you get it done before then. Because if you do not, then you just get a 0 on the last assignment of the semester, and that's no fun. All right. Have a good day, you guys. I will see you next year, hopefully, in person. Or in office hours like this week. That would be good too. All right. Bye, guys.